Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating DeepSeek-R1, a new large language model that's making waves in the ML community. It's a big deal, folks.
Absolutely. I've been following this closely. What makes DeepSeek-R1 so special? Is it just another LLM, or is there something truly groundbreaking here?
Oh, there's a lot more to it than just another LLM. It's open source, for starters, which is huge for reproducibility and community involvement. But more importantly, it's designed to excel at reasoning, particularly mathematical reasoning. Think OpenAI's O1, but with a publicly available training methodology.
That's impressive. So how did they achieve this remarkable reasoning ability? Was it just a matter of throwing more data at the problem?
Not quite. While the base model was trained on a massive 14.8 trillion tokens, the real magic lies in their training process. They used a three-step approach: language modeling, supervised fine-tuning, SFT, and preference tuning. But the SFT phase is where things get interesting.
Interesting. So what's unique about their SFT approach?
They didn't just use any old SFT data. They created a massive data set, 600,000 examples of long chain-of-thought reasoning problems. That's a huge undertaking, and getting that data was a multi-step process itself.
Wow, 600,000 examples. That's a significant investment. How did they even manage to create that much data?
That's the clever part. They used an intermediary model, a sort of reasoning specialist, to generate much of that data. This model, inspired by R10, was trained using reinforcement learning, RL, with automatic verification. This is key. They didn't need human labeling for every single example.
Automatic verification? That's a game changer. Can you elaborate on that?
Sure. For reasoning problems, especially coding tasks, you can automatically check the correctness of the generated solution. Linters, code execution, unit tests, all these tools can be used to verify the answer without human intervention. This dramatically reduces the cost and time of data creation.
I see. So this intermediary model generated the bulk of the SFT data, which was then used to train the final DeepSeek-R1 model. But why not just rely solely on the RL approach like R10?
That's a great question. While R10 showed impressive reasoning capabilities, it had some usability issues. Poor readability and language mixing, for example. The SFT step, even with the synthetic data, helps to improve the overall quality and usability of the final model. It's a hybrid approach, combining the strengths of both RL and SFT.
That makes perfect sense. A balanced approach. So what about the architecture of DeepSeek-R1 itself? Is it anything revolutionary?
Architecturally, it's a fairly standard transformer decoder stack, 61 layers to be precise. However, it uses mixture of experts, MoE, layers, after the initial dense layers, which allows for greater efficiency and scalability. It's a well-established architecture, but the training process is what truly sets it apart.
So in essence, DeepSeek-R1 represents a significant advancement in training methodologies rather than a revolutionary architecture. The focus on automatic verification and the clever use of an intermediary model are the key innovations here.
Precisely. It's a testament to the power of clever engineering and a deep understanding of the training process. The open-source nature of the model and its training methodology will undoubtedly accelerate further research in this area. And that, my friends, is why DeepSeek-R1 is such a big deal.
I completely agree. This is a fantastic example of how innovative training techniques can push the boundaries of what's possible with LLMs. Thanks for breaking it down for us.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.